Hello, students. We will start the third lecture of our relations and functions today. In the previous lectures, I have told you about the relations, types of relations, and operations on relations, and what are the basics of relations and functions. I have told you in the previous lectures 1 and 2. Also, I have covered the exercise 1.1 of NCERT. So you can see that lecture and refer to whatever you want to learn. I'm basically covering here the NCERT portion of your boards in of CBSE board for class 12th. So today we will see the next topic, that is types of functions. So in 11th class, I hope that you have learned about something in functions, that what are the functions actually, and some special functions like identity function, constant function, polynomial function, rational function, modular function, signum function. I hope that you all learn that functions in good manner. And in their graphs also you have been aware of that. So addition, subtraction, addition, subtraction, multiplication, and division of two functions have also been studied in class 11th. So now in mathematics, among disciplines, we will cover the types of functions here. Okay. So first of all, we will see what is the one function or injective function. First type is injective function. Okay. So it is written here, a function f. The function is defined as f, which is from x to y, means some set x to some set y. It is defined as one or injective. You have to remember the name. It is one or injective. Two names are there, one and injective. The images of distinct elements of x under f are distinct. That is, for every x1 comma x2 belonging to capital F, fx1 is equal to fx2, implies x1 is equal to x2. Otherwise, f is called many one. So I explain you this point, that what is it is saying. Suppose that you have a function and it has elements x1, x2, x3, so on, and you have the this is set A, this is set B, and you have here y1, y2, y3. Okay. So first definition, what that is given in your book, this definition is telling what, if x1 is related to some y1, okay, and x2 is related to similar to y1 also. So if fx1 is equal to fx2, which is fulfilling here, because fx1 is y1 and fx2 is also y1. So if it is true here, then it means that it implies that x1 is equal to x2. So it says that there are no two like two you don't have two other values of x1 and x2. These are not duplicate values here. We have only x1 for this. So it means that each element of x1, x2, x3 are related to only one element of b. Like a and b are there, y1, y2, y3. So each element is related to one element, and each element of b is related to other element. No two elements are related to each, x2 is not related to y1 like this. So it is not a one function. That is why the name also says that this is one. So one means that every element is related to only unique element, and like this is also related to unique element in the set B. So similarly, x3 will be related to y3, x4 will be related to y4. So it shows that pattern. Okay. I hope that you got that what is one. If x1, x2, x3 like this are related to y1, y2, y3 in this manner, like x1 is related to y1, then x2 is related to y1, then it is not one function. This will call as many one function. Okay, because one element is related to other element in the y, like b set, and the other element is also related to same element. So yani means one two elements are related to a single element in the set B. So it is called a many one function. Okay, so I will clear this part and move further. Yes. Now the second type of function which is given in your syllabus is onto function or surjective. So what was one function is called injective function, and what is onto function is called surjective. You have to remember both names, injective and surjective also. So yes, what is surjective function? Let's see. So if you have like a function f, definition is there given. A function f is from x to y set to be onto or surjective if every element of y is the image of some element of x under f. That is, for every y belonging to capital Y, there exists an element x in such that fx is equal to y. So, in simpler way, I will explain you what is it is saying. If you have a set A mean, and you have a set B here, and it has elements y1, y2, y3, and there is x1, x2, x3, x4. Okay. So if x1 is related to y1, x2 is related to y1, x3 related to y2, and x4 related to y3. Okay. So here all the elements of B are related to some element of A. There is no any element in B which is not related to A like some manner. So it is called what? Onto function. Okay. You don't have the condition that A um, all the elements, meaning that one element is remaining there. Meaning this is onto function. If it is not related, then it will be into function. Like if you have y1, y2, y3, y4, and here you have x1, x2, x3. Okay, if I like this, you have the relation, relation between the elements. So here you have y4 is remaining not related to anyone. Okay, it is remaining here. And it is not related to any element of set A. So it is called what? It is called into function because one is here left. One element is left here. It is called what? It is called into function. I hope that you got the definition of two functions that are mainly focused in your syllabus. One is one function and other is onto function. Okay. So now we will see some figures and cite out that whether it is of one function, onto function, into function, many one function. Let us see. So here, first example is given to you, and we have to tell that which type of function is it. So you can see here that each element of like x1 is related to only a single element of x2. Okay, x1 set has elements which is related to x2 in a single manner. So it is a one function, but it is not a onto function. Why? Because some elements of this x2 are not related. Like E is remain unrelated, F is also remain unrelated. So like this function is called what? This is one only, one only. Okay, and in the second example, you have see here one is related to B and two is related to B also. So it is not a one, but it is a many one. It is a many one function. Okay, and it is also not onto. It is into function. It is also into function because it is not onto. So it is into function. And here it is also into function. Why? Because some elements are remain unrelated to like x1. Okay. So let's find out what is the third function. So here you can see that 1 and 2 are related to same element in the set x2. So it is not a one function, it is a many one function. Okay. But it is a onto function. Why? Because A, B, C all are related to some element in set x1. It is a onto function. Till now we have not got the like on one and onto all the conditions. But in the fourth example, you can get that it is a one function also, because each element is related to single element in the set V or set x2. So it is a one function also, and all the elements are also like related to some element. No one is related, no one is remaining unrelated. So it is one also, and one like onto also. So when the both conditions are fulfilled, like one is also there and onto is also there, so function is called what? It is called bijective. So I will call this function as bijective function. It is very important to remember that if the function is both one and onto, then it is called what? Bijective function. So you have to remember these points. Okay, bijective is what? Like what is bijective function? So those conditions should be fulfilled here. Then the function is called bijective function. Okay. Let's move further and see the next topic, that what is it. I will clear this drawing and let's move. Okay, so you can also observe there that if a function is onto, then the range of like f is always equal to set d or set second. Here it is given also. That range, because all the elements are related to some element of x1 or like a element, a sets, so the range will become equal to the set second. So here the set like set y will become the range. Okay. So it is also given here that a function f x y x to y is said to be one and onto bijective if f is both one and onto. Okay. So I have told this you in the previous topic also, that it is a bijective function. Let us see some examples in your book. So example 7 is given to you. Let A be the set of all 50 students of class 10th in a school. Let f is a function that is from A to n. B, a function defined by fx is equal to roll number of the student x. Show that f is one but not onto. Yes. So we have to show that the function is one but not onto. Okay. Uh, so what is n here? Can you tell me that what is n here? Because it is written in the question that let A be the set of all the 50 students of class X, and function is given from A to n. Okay. So n is what? N is natural number set. Okay. Set of natural numbers. So if you have 50 students in the class, just a second. Like I will make the image of this. If you have 50 students in a class, this is set A, and it is like roll number from 1, 2, 3, 4, so on, go to 50. And here is a set of natural numbers. The natural number starts from 1, 2, 3, so on, up to infinite. Okay. So, yes, fx is what? Fx is function roll number of student x. You know that roll number is unique, like unique number. The roll number of a student is a unique number. Each student has different roll number. No two students have similar roll number. So it is a unique relation. So if first student have first roll number, then it will related like this. Second has second, then this is related to this. So I can see that the pattern is following what? This pattern is following one criteria. one function criteria. But do you have like after 50, do you have any relation with set A to N? No. Why? Because 50 is the total number of students in like set A, because only 50 students are there. But after that, 51 is related to what? No 51 is there. So here 51 is remain unrelated. Similarly, 52 remains unrelated. All the elements after 50 are remain unrelated. So this set is not completely related to set A. So this set become like this function become into function, not onto but into. So it is not onto. So we have proved that it is not a onto function, but it is a one-one function. What is asked in the question that show that it is one-one but not onto. So hence it is proved. Let's see the next example of your NCERT. Okay, okay. Let's remove this part. So second example, that is example 8, you can do it by yourself because it is similar to the example 7 which I told you. So I hope that you can do it by yourself and it is a easy question. Okay. Let's move to the next example. Prove that the function f real number to real number given by fx is equal to 2x is 1 1 and on 2. Okay. So yes, if you have a function like 2x, so it is a like if I draw the graph of this function, y is equal to 2x. Yeah. So it is a line which is passing, it is shown here, which is passing through the origin. Yes. So one method to check that whether a function is 1 1 or not, you draw a line parallel to what? Parallel to x axis. If it cuts at a one point, and it is a 1 1 function. Here also it will cut at one point. At any point you draw the like line parallel to x-axis, it will cut only at a single point to the given function. So it is a what? It is a 1 1 function. Okay, 1 1 function. And also it is onto. Why it is onto? Because it will go up to infinite. Y to x will go up to infinite. It will go like this and it will go like this also. So it will cover minus infinite to plus infinite all the points. Okay, because it is defined from real number to real number, and that shows that all the real numbers will be related to some real number if I see the range of this, because domain is also real number and range is also real number. So each element will be related to sub element of like set A to set B. So it is both 1 1 and on 2. I hope that you got it. Yes. Now let's move to the next example. So example 10 is telling that show that the function f n to n, that is from natural number to natural number, given by f1 is equal to 2 is equal to 1 and fx is equal to x minus 1 for every x greater than 2 is on 2 but not 1 1. Yes, so we have to prove that this function is on 2 but not 1 1. So let's try to solve this question. Okay, just a second. Yes. So you have the function f that is defined as f1 is given as f2, f1 is given as f2. So you can see that 2x has the same y, because f1 is also 1, f2 is also 1, so it must not be 1 1. 1 1 criteria is not fulfilled here. Okay, not 1 1. And it, so it has been shown that it is non 1 1, but it is on 2. Yes, uh, fx is given as x minus 1, and it is from natural number n to n for every x is greater than 2. So if x is greater than 2, if I put here uh, x is greater than 2, so x will be values like 3 comma 4 comma 5 because it is natural number. So 3 comma 4 comma 5 comma 6 up to so on and go to infinity. So yes, each element will be related to like some element inside n. And n is like 1 2 3 4 up to infinite. Okay. Uh, no. X is that. Yeah. X. So it will be also 3 4 5 6 like this. So fx is x minus 1. So you put here x is equal to 3. It will become 2. Okay. So yeah, this will start from 2. 2, 3, 4, 5 like that. So 2, then 3 will come, then 4 will come. So each element of set A will be related to some element of set B. So this is on to because you know that we can choose as x as y plus 1 such that fy plus 1 is equal to fy plus 1 minus 1 that is equal to y. What it is showing that it is a onto function, which I told you that if you take any number from set n of A, then it will be equal to some like it will be related to some element in the set B, which is also a natural number. So yes, it is an onto function. I hope you got this. So let's move to the next example. The example 11 is asking that show that the function f that is from real number to real number defined as f is equal to x square is neither 1 1 nor 1 2, like non 2 and neither 1 1. So it is also a very good example, and you have to remember these examples also. Like this will be asked in your competition levels also. So if fx is equal to x square, you know that fx is equal to x square, the graph will be like parabola. So it is showing in the like figure also. So if you draw the line that is parallel to x-axis from here, it will cut at 2 points. So it means that at 2 points you will get the for 2x you will get same y because y is same here. So at 2x you get the same y. So it is not a 1 1 many one. It is a many one function. Okay, and onto function is also not covered here because you have the function from real number to real number, but your domain is real number, but range is only positive real numbers. Okay, it will contain only non-negative real numbers like 0 1 2 3 4 up to so on till infinite, but it will not cover the numbers like -1 -2 -3 -4 up to minus infinite. So that is why the range is not fulfilled by all real numbers. So it is not a 1 1 like onto function. So it is a into function. So both conditions are true here. It is not many 1 1 function and not onto function. So I can say that the function is not 1 1 and onto also. Okay. It is not surjective also and not injective. Let's move to the next topic or next point left. What is the next thing we have to learn? So I will use the now some other examples are also given in your NCERT book. So I will not cover all the questions because some questions are there. You can see these examples and solve by yourself. If you have any doubt, you can ask me personally. If you want any live sessions or doubt sessions or any private session one to one, then you can ask you can comment also. Okay. Oh, and there is exercise 1.2. and like some questions are given in this. You have to solve this question. So I assume that you can solve these questions, and because I have told you some examples, so you can solve by yourself some examples. I will take one or two questions from this and try to solve for you. Let's see that which question is good for you. I will take question 4 from exercise 1.2. Let's solve this. So that the modulus function f real number to real number given by fx equal to mod x is neither 1 nor 1 on 2, where mod x is x if x is positive or 0, and x mod x is minus x if x is negative. Okay. So you have also aware of modulus function. I hope that modulus function graph is what? If it is for real numbers, so you have this y-axis, x-axis. Modulus function is V type of graph for all real numbers. So it is like this. So if you draw any line parallel to x-axis, x-axis if you draw, it will cut at 2 points. So what is this? This is not a 1-1 function, which I have told you the condition. This is not a 1-1 function. Okay. Yes. And I have to show that it is not onto also. So how you will show that it is not onto? Because all the real numbers are domain in the domain, like minus infinite to plus infinite, you have all the numbers are in domain. But like range, for range you have only range covers only 0 to infinite part. Okay? So you have the function defined from real number to real number, but all the real numbers are not included inside the domain. So it is not a onto function also. Okay, not onto function. So I hope that you got this point, and also this question fourth, that modular function is not menu and not 1-1 and onto also. So let's see another question from this exercise. I will solve only one or two questions. So example 6, see the example 6 or question 6. Let A is equal to 1, 2, 3, B is equal to 4, 5, 6, 7, and let F is equal to 1, 4, 2, 5, 3, 6. So F is the function which is containing the order pair like from A to B. So element like order pairs are here 1, 4, 2, 5, 3, 6. It is a function from A to B. Show that F is 1, 1. Yeah, so F is 1, 1 because every element of F is related to unique element of set B. See here 1, 4 is there, 2, 5 is there, and 3, 6 is there. So it is a simple question. You can solve by yourself also. It is a 1, 1 function. Okay. So I hope that you can solve all these questions because all are easy questions here. And if you have any kind of like problem in any question, you can comment in the chat box, or you can also ask me. So I will explain you that question. Okay. Let's move further and see what is the next topic in your syllabus. So the next topic is composition of function and invertible function. So I will tell you what is the composite function and what is the composition of function, and also what is the invertible function. Yes. So let f is a to b and g is b to c be two functions. So there are two functions. Let f is a function from a to b, and g is a function from b to c. Okay. Then the composition of f and g denoted by GOF. Yes. So composition is what? The mixture of both functions. It is denoted by GOF, and it is defined as the function GOF is from A to C. So you see here that you have the function from A to B. From here A to B is function and B to C is function. But if you want any function from A to C, you can use directly the relation GOF. What is GOF? It is called as G of fx. Yes, G of fx. Okay. I hope you got this. That I have x here and fx here, and I have to like find the g function from like which is related to fx also. So it will be what? G of fx. G of fx. Okay. It will defined as G of fx for every x belonging to capital A. Yes. So you have to remember this point, that how it come and what is the like relation between these two functions fx and gx. So yeah, I should remove this part. So how this comes, that why it is like g of fx from A to C, why it is like g of fx? Because you have the relation like function from D to C, that is g, and if you want any function from A to C, you have to travel two paths. You have to first cover the x to fx path. Yani it means you have to cover x to fx path first, then you have to cover g to g fx path, like other. Okay, like you first calculate this x to fx, you calculate this, and then the relation g of fx will come like this. Okay, that will contain the g of fx part. So we will see some examples, so you will clearly like see that how it comes. It will be clear to you that what is the actual meaning of this. So example 15, what is it telling? Let's see. Let f is 2 comma 3 comma 4 comma 5 is a function from like this 2 3 comma 4 comma 5 comma 9, and g is a function from 3 comma 4 comma 5 comma 9 to 7 11 15. And these functions are defined as f2 is equal to 3, f3 is equal to 4, and f4 is equal to 5, and g3 is equal to g4, that is equal to 7. Yes. And g5 and g9 are also equal to 11. So we have to find g of of. So here we have g of of 2. What is g of g of 2? What it come? So I already told you that g of f can be written as g of fx. So g of f2, we will write it like that. Here g of f2 is written like g of f2. Okay, g of f2 is written g of fx or g of f2, and f2 value is what? 3, because f2 is given here 3. So I will put inside the g, that is 3, and g3 is what? G3 is given as 7. So the value of g of f2 is 7. Similarly, g of f3 is g of f3, and it is equal to g of 4, because g of f3 is equal to 4. So that is why g of f3 is equal to g4, and that is coming out to be 7. Similarly, you can find all the other like terms also. GOF of 4 is equal to GF4, that is equal to G5 equal to 11, and GOF of 5 is equal to G of 5, that is equal to 11. Yes, so this is simple. You can do yourself all other examples how to find the G of OF, so or FO of OG. You can find that. Yes. So let's move further and see that what is the next thing that you have in the syllabus. I should be of this drawing. Yes. So here is another example that is good. Example 17, show that if f is a function from R real number minus 7 by 5 to real number minus 3 by 5, and it is defined by f is equal to 3x plus 4 upon 5x minus 7. Okay, and g is r minus 3 by 5 to r minus 7 by 5. It is defined as gf equal to 7x plus 4 by 5x minus 3. Then FOG is equal to IA and GOF is equal to IB, where A is equal to r minus 3 by 5, B is equal to r minus 7 by 5, IAX is equal to x, and for every x belonging to A, IBX is equal to x for every x belonging to B, are called identity functions on set A and B respectively. Yes. So let's solve this question. So we have here G O f x is what? G of fx. And what is fx here? That is equal to 3x plus 4 by 5x minus 7. So I will put inside this G of fx. So in G of fx, I will put the fx value that is equal to 3x plus 4 upon 5x minus 7. And now I will find the G of this. So what is G of x? This is defined as 7x plus 4 by 5x minus 3. I have to put the x value equal to all this value. So I have put here 3x plus 4 upon 5x minus 7. And after simplifying it, I will get it like x. So I am getting g of O of x is equal to x. And FOGX, if you solve that also, you will get it equal to x. Okay, so here the g of O of x, FOGX you can find here. Similarly, how I found g of O of x, you can find out FOGX also. F of gx you can write here, then you have to put the fx value, and in that you have to put the 7x plus 4 upon 5x minus 3. It will also come equal to x. So from both the points we get g of O of x equal to x for every x belonging to b, and for gx equal to x for every x belonging to a, and this implies that g of f is ib and f of g is also ia. So these are both are identity elements, identity functions, because you are getting g of O of x also x and f of g x also x. Identity function is what? If you have the relation like x related to x itself. So this is what, and this is identity function. Okay. So I hope that you got this point, and we will now check that what is the example 18 given in your like syllabus. Let's see. Yes. So example 18 is what? So that function a to b and g, that is b to c, are 1 1. Then g of a to c is also 1 1. Okay. So if a function f is given from a to b and g is given from b to c are 1 1, both are 1 1, then g of a to c is also 1 1. So it is a simple one. Because suppose you have g of fx1 is equal to g of x2, then g of fx1 is equal to g of fx2. This implies that fx1 is equal to fx2 as g is m1 1 1, that is 1 1. So this implies that x1 is equal to x2 and f is 1 1, and g of f is 1 1. Okay, so it is a simple problem. You can prove it by yourself after like GOFX1 and GOFX2. You can write them by expanding and cancelling out the G function both sides. You will get x1 is equal to x2. That is f is 1 1. So you will get also that GOF is also a 1 1 function. Now, in the next example, what is this showing? It is also similar to previous example 18. You can solve it by yourself. Okay. Other also examples are given here in the question, like your syllabus. So try to solve these and make sure that you can solve these functions. And yeah, I will take this example 22. So what is it asking? Let f is the function from 1 to 3 to a, b, c, b, 1, 1, and onto function given by f1 is equal to a, f2 is equal to b, and f3 is equal to c, shows that there exists a function g a, b, c to 1 to 3 such that g of f is equal to ix and g f of g is equal to iy, where x is equal to 1 to 3 and y is equal to abc. Okay. So we have to show that the relation is invertible like that, or identity relation is this is given like identity function. So consider GABC to 1 to 3 as GA is equal to 1, GB is equal to 2, and GC is equal to 3. It is easy to verify that the composition GOF is equal to IX is the identity function on X, and the composite for G is IY is the identity function of Y. Okay. So these both is our identity function that is telling in the question. So you have this relation that is asked in the question, that it is the invertible function. Okay. So from that example we have the definition: a function of x to y is defined as to be invertible if there exists a function y to x, meaning that a function from x to y is invertible, meaning if x to y is a relation, like any relation is there, so y to x is also some relation, such that GOF is equal to like Ix and FOG is equal to Iy. The function is called the inverse of Fy, and it is noted by F inverse. Okay. So if you have the function from f from x to y, and you have similar like condition g is function here, and it is from y to x. If it is following here, so you have what? GOF is Ix. Okay. GOF is Ix, like this contain x of I of x there, and f of g is what? Iy. So function g is called the inverse of f. Yes. And the function f is called invertible. Also, you can show that g is equal to f inverse, and f inverse sign is f to the power minus 1. Thus, f is invertible, and then f must be 1, 1, and onto, and conversely. Okay, so if a function f is 1, 1, and onto both, then only it will be invertible also. Why? Because this condition should be fulfilled to be function invertible. Suppose that you have a function like this, like parabolic function. Okay. So like x, you have x, like this x1 and this x2. You have both x have same y. So if you invert it, so y has also x1 range and like relation, and x2 also does. So it will not be a invertible function. If you like converse it, so it will not be invertible function, because it is related to two unique elements of set B. That is why it should be 1, 1 also, and on 2 also. On 2 is why? Because if any element of set B is remaining here like unrelated, so you have x1 comma x2 comma x3, some element will also be not related to y2, like this will be remaining as not relation with any element of this. So it will not be a function, because in function all the elements of set A must be related to some element of set B. That is why it should be on 2 and 1, 1, all both conditions should be fulfilled here. Okay. So I hope that you got this point, that what is invertible function and what are the conditions to be followed to be a invertible. That it should be a 1, 1 also, and may like on 2 also in the given particular interval. Whatever the interval is given for the function, it should be 1, 1, and 1, 1, and on 2 both in that interval. So yes, I hope that you got whatever I told you in today's lecture. I covered the points like types of functions, what is a 1, 1 function, what is a many one function, what is a onto function, and what is a into function. So these points I covered today, and also I have taken some examples of your NCERT syllabus, and some questions also I have solved for you. So in the next part, I will take some other examples and try to solve it for you. Till now, this is all for your today sections. I hope that you got the points which I've told you. If you have any kind of doubt or any types of concern, you can comment or ask in the chat. Or also, if you want any private session or one-to-one session, you can also tell us. Okay. But for today, this all. Thank you. I'm Yi Limbornas Lecture. What is remaining? Thank you and good job.